Hello, everybody. My name is Masood Olia, and I'm a faculty in School of Engineering at Wentworth Institute of Technology, and I'm here with a problem related to the subject of dynamics and specifically to the topic of dependent motion. So let me close my uh, camera. There we go. So I want to solve this problem for you, and if you look at, let me just move this down. Sorry, guys. So this is the statement of the problem. It says that if the speed of this crate, the crate here, is to be 4 meters per second up, right? What should be the speed of the motor here, which is really the speed of this cable, point A? So what should be the speed of point A? Find VA such that the speed of the crate is what? Is 4 meters per second up. So this is a typical what we call dependent motion problem. And I want to show you how you could work this problem. So in this problem, one thing we notice actually is that there are a bunch of ropes here and a bunch of pulleys. So I'm going to actually use different colors to show you different ropes. So let me start with black. So one rope is this guy. So it's going around here, and that ends here. So the other rope I'm going to use red is a smaller rope going around this pulley, right? And then finally, let me show you the last one, which I'm going to use blue. So this is going to be this rope. So altogether, we have 3 ropes, right? So I'm going to try to figure out the length of these ropes. So I'm going to call the length of rope 1 L1. The red one I'm going to call L2. Or I'll just put it over here because I need this as space. Sorry, guys. So L2. So L1, I used black. And then finally, I use blue for L3. So I want to find the length of this rope. But in terms of what? In terms of the movement of these pulleys and points. So you always need a reference, a non-moving reference, to keep track of the position of these points or pulleys. So the things that are important to us is velocity of this point. So I'm going to actually call this position of A. And I picked this reference. The reference basically has to be a non-moving point. Okay, I could have actually picked the reference to just show you that. Another option you have is the reference could have been actually the top of this pulley or the center of this pulley. So it really doesn't make any difference as long as it doesn't move. And for this guy, D, I'm going to use this reference. It doesn't really matter again. It's a non-moving reference. I'm going to call it S sub D. For C, same story. Call this S sub C. And then for B, now look at B and E, right? If I call this E, velocity of B and E are the same. So basically, I know what velocity of B is 4 meters per second, right? So I'm going to call this finally S sub B, okay? Let me clean this up for you here. So basically, I have to relate S sub B to S sub A in a way, because B and E are the same thing, right? So try to figure out the total length of the rope for each one, right? In terms of these variable SA, SP, SC, and SD. So let's start with the rope number 1, L1, okay? So look, L1, the length of this rope is SA, right? Then what is that? You got 2 SD, one here and one here, right? You see that? That's it. And then you might say, well, wait a minute, what about the piece that is going around here, this pulley and this pulley? Well, they're just constant, so they're not really important. Like if the parameter of a pulley is 2 feet, well, you got half a 2 feet, and maybe the other pulley has a different length different dimensions. So they are constant, though they don't change. All right. So let me now write the equation in red for rope number 2. So let's go look for rope number 2. So this one, this piece, as you can see, is S sub C. But now look what happens here. What about this piece here? This piece actually is the difference between S sub C and S sub D. So that makes it interesting. So let's hold on to that too. And then finally, let's go to rope number 3. I'll use blue. So what do we have again? Again, you see this? This guy, sorry. This guy is what? S sub B, right? And what about this piece here? This piece is the difference between S sub B and S sub C. So S sub B minus S sub C. So let me clean these up for you. So L1 becomes S sub A plus 2S sub D. L2, if I clean it up, is 2S sub C minus S sub D. And then finally, L3 is what? 2S sub B minus S sub C. So then go ahead and take the derivative of each one of these. So the derivative of the first equation, meaning the time derivative. Derivative with respect to time, right? And I have, by the way, other videos that shows you more detail of this, problems like this. So the derivative of a constant is 0. The derivative of a position A becomes velocity of A. The derivative of position D becomes velocity of D. So here's one equation. Relating velocity of A to velocity of point D or pulley D. All right, similarly, for the second equation, taking the time derivative of that, what do we have? L2 equal 2SC minus SC, SD. So again, 0 to velocity of C minus velocity of D. And then finally, the time derivative of the last equation, which is rope, the blue rope, which we called it L3, right? Gives me what? Again, the derivative of a constant L3 is 0. That's 2 velocity of B minus velocity of C. So now look, guys, my eventual objective is to relate velocity of A to velocity of what? B, which is the same as this crate. So look, I'm going to say, look at this. Velocity of D here is what? 2VC, right? And velocity of C is what? 2VB. So if I take this and put it here, velocity of D becomes what? 2 times velocity of C, which is 2 velocity of B, becomes 4 velocity of B. And eventually, if I take this and put it right here, I have achieved my goal, which is velocity of A plus 2 times velocity of D. But what is velocity of D? It's 4VB. So finally, the final equation is VA plus 8VB equals 0. So let's say if the crate velocity of B or E, which was given to be 4 meters per second. So if you take that positive, VA plus 8 times 4 positive equals 0. So velocity of A would be negative 32. Negative 32 means what? It's moving downward. So in order for this to happen, for the crate to have 4 meters per second up, the point A or the motor has to give the rope a velocity of what? A velocity of 32 meters per second down. So I hope you liked this problem. As always, I appreciate if you like the video and subscribe to my channel. Thank you, and I will see you soon.